In this video, I'm going to solve a set of limits that I have in the right over here. And in order to solve them, I'm going to use this super nice piecewise function, f of x, which is divided in 3 pieces here. Now, first, I'm going to draw this line. I'm going to draw a line here. Luckily, I'll be able to. Well, it's just not that bad. Let's go this line. Goes from negative infinite to positive infinite. Now I'm going to locate the intervals, only the boundaries of the intervals here on this nice line. So I have in this bar here the 0 and I have the 4 here. Now I'm going to locate for each interval or each section which piece of this f of x is good for which interval. Now for the values for x lesser or equal than 0, this one would be the good one. So I'm going to place it here on the left of the 0. Now the second between this 0 and 4, I'm going to locate the x plus 1 in here. X plus 1 is good for all the values between 0 and 4. And the last one just goes for all the values that are greater or equal than 4. I'm going to locate here the x squared plus 2. Now let's get to the actual limits. The first one is this one, the limit for f of x when x approaches to 0 from the left. From the left of the 0, we have to use this statement, this piece here. So I'm going to write it just as this should be. The limit when x approaches to 0 from the right, for the right, we have to use the negative 2 times x plus 1. I'm going to use parentheses because I think it has more order. So as we can see, we have no, if we substitute the 0 here, we won't get it undefined. So I'm just going to substitute right away. Negative 2 times 0 plus 1. And at the end, we've got that the limit for f of x when x approaches to 0 from the left will be equal to a 1. Now let's go to the second one. The second one is the limit for f of x when x approaches to 0 from the right. From the right of the 0, we have to use this one here, the x plus 1. So I'm going to substitute it. It will be the limit when x approaches to 0 from the right for x plus 1. Again, we have no undefined here. We substitute the 0 in here. So I'm just going to substitute right away. Be 0 plus 1, and we've got it that the limit for f of x when x approaches to 0 from the right is equal to 1. Now the third question, it's what's the limit for f of x when x approaches to 0? That is the general limit. So in order for this general limit to exist, the previous two must be the same, must have the same value. The limit from the left, we've got that it's equal to 1, and the limit from the right as well is equal to 1. So therefore, the limit for f of x when x approaches to 0 would be equal to 1. Okay, let's move to the next one, which is the limit for f of x when x approaches to negative 3. Now, negative 3, it's in no boundary. It's not on the 4, not getting to the 0 or the 4. It's actually within this interval here. It falls completely within this interval. And as we have here a linear function, we can just assume that the behavior of this linear function is just continuous, has no holes, there is no asymptote, there is no roots in here, so we can just plug in this negative 3. I'm just going to write the full statement here. How will we look? The limit when x approaches to negative 3 for negative 2 times x plus 1 will be equal here. I'm just going to substitute right away the negative 3. So it would be a negative 3 times a negative 2 times negative 3 plus 1. And we got here, it is a 6 plus 1 will be equal to a 7. And that will be it for this limit. Now let's get to the next one. Here is the limit for f of x when x approaches to 4 from the left. So from the left of the 4, we want to get to the left of the 4. I'm going to draw the arrow below better. In here, left of the 4, we have to use this x plus 1. So I'm going to write a full statement here. limit when x approaches to 4 from the left will be here for x plus 1, and we have just to substitute right away. It'll be 4 plus 1, and we get a 5 here. 5 is the limit for f of x when x approaches to 4 from the left. Now let's get the next one, 4 from the right. Here, I'm going to get a bit faster here. Right at the 4, it's this x squared plus 2, so I'm going to write here the limit when x approaches to 4 from the right. We have to use the x squared plus 2. I'm going to use parentheses again. Just plugging in the 4 here would be 4 squared plus 2, and we got this 16 plus 2 would be equal to 18. Now, this the 18 would be the limit for f of x when x approaches to 4 from the right. Now, the next question is, what's the limit for f of x when x approaches to 4? That is the general limit when x approaches to 4. In order for it to exist, it has the previous two, the 4 from the left and the 4 from the right. They have to be, they must have the same value here. So we can see they're different. This one is 5, 4 from the left, and 4 from the right is 18. So here the limit of f of x when x approaches to 4 doesn't exist. And that will be it for this exercise.